Hello, everybody. Today we're going to be looking at 3.3. 3.3 is division. So last unit or last section we looked at addition, subtraction, multiplication. Those should have all been review topics for you today. But today we're going to be looking at division. Division is the last thing we really need to do for this section before the test for the first half of Unit 3. So the first part asks us to factor the expression completely. Factoring is important because it lets us get rid of some things so that we can describe polynomials or expressions better. Excuse me. So I'm going to start out. When I factor, I want to make sure that I'm factoring out things that I can factor out. And I want to start out by doing what we call a greatest common factor. It's the biggest number I can divide or variable I can divide every part of the function by, or the expression by. So looking here, I've got a t, I got a y, I can't bring any variables out. But I've got a 13, I've got a 39. Both of those are divisible by 13. So that means I can pull a 13 out, and I'm left with t, 1t, but the 1 doesn't matter, plus 3y. Let me draw that plus a little better, plus 3y. There we go, that's a little better. Okay, for this second one here, I can pull out a 3. And then I can also actually pull out a k here because I have k's in both parts. So I'm going to pull out a 3 and a k. For this first one, I'm going to be left with just 1k. And for this second one, I'm going to be left with just a minus 1. Okay. For this next one, same idea. I'm going to take 5. Look at 5. Well, I got a 1 there, so I really can't probably pull any numbers other than 1. That isn't going to do anything. I have 2 a's here, but only 1 a here. So I can pull out at least 1 a. B squared, b, 2 b's, so I can only pull out 1 b. So then I'm going to be left with 5 a, b minus a, because I lost this b, plus 11 b. Okay, and that's going to be all I'm going to be able to do with that one. This one we're not going to look at for right now. This one we'll look at, these last two we're going to look at more later. But these go back to diamond and box. We're not going to need that for today. We're going to need that for next unit. So I don't want to overload you guys today because this is a fairly longer lesson. So let's just put those last two on hold for now. We'll bring those back in next section after the test. So today we want to look at, how can you use factors to divide? Because if I know something is a factor or something that can be pulled, it could be pulled out, then I should be able to divide it. And whatever's left would be part of that function. And it should be a nice function for us in a polynomial if it is truly a factor. So starting out, for this first one, looking at just this first part, I'm going to pull an x out. I'm going to do a GCF, pull an x out. I'm left with an x squared plus 1x minus 2. Okay. Now, I could factor this a little bit more, but I don't need to right now, so I'm not going to worry about it for right now. And then this is divided by x. Remember, division and fractions are kind of the same thing. Well, what happens here? Those x's cancel out, and I'm just left with x squared plus x minus 2. Okay, now we're going to talk about this later, but I do need to be careful that I got rid of an x at the bottom, but we're not graphing right now, so we don't need to super worry about that for right this second, but that is going to be a problem for us later. Okay, right now we're just looking at, can we divide these things, and what do we get when we divide them? Okay, using the same idea over here, now I do need to factor this, and I'm just going to do this for you guys today, but we would use, diamond and box here. But it's going to factor in x minus 2, x minus 1. And that's all over x minus 1. So I can cancel here as well, and I'm left with x minus 2. Okay, well, what if it's not nice? Or what if it's something that I can't just look at and go, okay, well, I know these are the factors of it because it's a quadratic. Or it's a nice cubic that just kind of factors nicely. How do I go about doing this then so that it works nicely still for us, but we don't have to worry about doing that factoring that we maybe can't do. So let's look at that. We're going to start off with this guy. So thinking back when when you did division a long time ago. So for example, when you did, 27 divided by 4. Okay, well, if it was divided by 3, that's easy, that's 9. Okay, but for 4 here, 4 isn't a nice factor of it, so I need to do this, right? And then if you think back again to, third or fourth grade when you did this, well, you would go, okay, I know that this is going to be 6, and then 24, and then 3, and then I pull down a 0, right? Starting to remember this? And then it's going to be 7, 28, 2, pull down another 0, and then we get a 5, and that was our answer. Okay, we called this long division. That's exactly what we're going to do here, but instead of having just a number and a number, we're going to have polynomials. We're going to do the exact same process. Pull down, subtract, pull down, subtract, pull down, subtract. Okay, so we're dividing this by this. So this is what's going to go outside, the x squared plus 3x plus 2. 2x to the fourth plus 3x cubed. Now I need to be careful here because I don't have an x squared term. Any terms that are missing, and this is very important because I'm going to show you 2 ways to divide today. Anytime a term is missing, we must put a placeholder. Okay, and in this case, we're always going to use 0 because I can add 0 to something and not change it. Plus 5x minus 1. Okay, so I've got to set out. Step 1 is to look at the front terms. How can I go? What could I multiply x squared by to get 2x to the fourth? That's the question I need to ask. I need to look at those front terms and say, what can I multiply x squared by to get to the other front term? And in this case, it's going to be 2x squared. Well, for simplicity's sake, it's usually better to keep things lined up. So I'm going to put 2x squared right here. I'm going to take this. I'm going to multiply it to all 3 parts here. 2x squared times x squared is 2x to the fourth. 2x squared times 3x is 6x cubed. 2x squared times 2 is 4x squared. Now remember, on the long division, we just subtracted. That's exactly what we're going to do here. So if you were struggling with this subtracting in 3.2, I would make sure you're getting extra practice with that because you're going to need it here. You're going to subtract. Okay, now if you did it right, this first one should always cancel. 3x cubed minus 6x cubed, I get negative 3x cubed. 0 minus 4 minus 4x squared. Bring down the next term. Okay, I'm starting to see what we're doing. We're going to bring down the next term, bring down the next term, bring down the next term until we get to the last one. Nice thing here is we don't need to go into decimals. Okay, so that's going to be the one different thing that we don't have to worry about is we don't have to worry about decimals. So again, I'm going to look at my new front term, my front term. How do I get from x squared to negative 3x squared? Well, I'm going to do negative 3x. Negative 3x cubed, multiplying this to the front. Negative 3x times 3x is negative 9x squared. Negative 3x times 2, negative 6x. Okay, now please be sure you're being very careful when we're subtracting. Okay, so minus 3, minus, positive. So this is going to cancel. Minus 4, minus, so plus. Negative 4 plus 9, 5x squared. 5 minus minus again, plus 11x. Drop down, minus 1. How do I get from my new first term from the first term of the outside? I'm going to multiply by 5. So plus 5. Let me not do that actually. 5x squared. 5 times 3x is going to be 15x. 5 times 2 is 10. Again, subtracting cancels. I'm going to end up with negative 4x minus 11. Okay, now once you run out of space, once there's nothing else to pull down, you do not need to do decimals here. It's impossible. Don't try it. Okay, you do not need to go any further. You're done. Now, something to keep in mind though is when we did that with long division, we said that this was a remainder. Okay, so we have this as our quotient, but we have a remainder of this. So I'm going to say plus negative 4x minus 11 over the original function, x squared plus 3x plus 2. Okay, so just running through this one more time, I'm going to take what I'm dividing by, put it out front, what I'm dividing from, put it inside. I'm going to check and make sure that I check for any zeros that are missing. I'm then going to look at the front term and go, and the front term of both, and go, how do I get from the outside to the inside? I'm going to multiply by this. I take that, I multiply it back to all the parts to get here. Once I do that, I subtract. And then I just rinse and repeat. How do I get from x squared to negative 3x squared cubed? Pull down, multiply, rinse and repeat over and over and over again. And then here is my answer. Okay, again, on this last step, whatever your remainder is, you're always going to take it and you're going to put it over what you started with. Okay, doing one more just for practice. If you felt confident on that one, feel free to skip this slide or this part of the video. X squared minus x plus 1. X to the 4th. Placeholder for x cubed. I don't have an x cubed, I need placeholder. 2x squared minus x plus 5. How do I get from x squared to x to the 4th? X squared. Multiply x squared to all the parts in the front. X to the 4th. Negative x cubed. X squared. Subtract all of these. Cancels. 0 minus negative. Not going to be a plus. 2 minus 1. Okay, how do I get from x squared to x cubed? After I drag down, I'm going to go by x. X times all of this, x cubed minus x squared plus x. Subtracting cancels. 1 minus negative 1 is going to give me 2x squared. Negative minus negative minus 2x. Drag down. Same process. 2x from x, 2x squared from x squared. It's going to be plus 2. 2x squared minus 2x. And then 2 times 1 is just 2. Subtract. These cancel. These are actually going to cancel too. Minus 2, minus minus plus. So this is actually going to cancel too. That sometimes happens. That's okay. And then 5 minus 2 is going to be 3. So my remainder here is 3. So plus 3 over what I was dividing by my divisor. x squared minus x plus 1. Here is my answer. Okay, now that works every time. So if you feel like you've got polynomial long division, stop here. There is a shortcut for some problems. Okay, so this is one of those times in math where we have a little bit longer way of doing something, but it works every single time. So if you're one of those people who works better with just taking it and going, you know what, this works for me, let's stop right here, then this is where you stop. Okay. If you feel like that you could, use more tools for faster ways of doing things, this is a good ACT trick. So I caution students, don't just stop the video because you don't want to watch anymore. But if you feel like that this is going to work for you and you can do a good job with it, then you can stop here because this will always work. Doesn't matter what the function is. If though, for example, in this next one, if you have a binomial that is x plus or minus some number, then there's a faster way of doing this. Okay, now I want to be careful. There cannot be anything here. There cannot be a coefficient. If there is a coefficient, this process does not work. Even if it's negative, even if it's just -1, this process does not work. So it works in this case because I have x minus 3. Okay, no coefficient on x, and then it's just plus or minus a number. In this case, -3. Okay, so what we want to do here is first remember placeholders. That's always going to be true. So there's really a 0x here. What you want to do for setup is draw this. Okay, you're going to take your constant, put it over here. And then you're going to put all the coefficients. So 0, 4, -1. Okay, now it is very important that you put zeros. If you do not put zeros, this will not work. It will give you the wrong answer. Okay, so both with long division and what we call synthetic division, which is what we're doing now, you have to have the zeros there. Okay, we're going to take this number and change the sign. So instead of -3, I'm going to have a +3. I'm going to put that right here. So I have +3, -1's coming from here, 4, 0 from the placeholder, and 9 from my constant. Okay, now this is not I promise this is not a hard concept that I'm about to do. Students like to overthink it. Listen very, very carefully. It's really not that bad. I'm going to take the first number, I'm going to drop it down. I'm not going to do anything to it. Nothing to it. Just bring it straight down. Okay. I'm then going to go up. Every time I go up, I am going to multiply by the number in the box. So we're always going to multiply by the box. So I'm taking -1 times +3, and I'm writing it right here. So every time we go up, we're going to multiply by the number in the box. Every time we come back down, other than the first, we are going to add. Nothing fancy, no subtraction. Okay, so the big point of confusion some students have is we subtracted here, we are adding here. There's no subtraction, which is why a lot of students like this better because they don't have to remember double negatives. Okay, 4 plus -3 or 4 minus 3 is just 1. I go back up, I'm multiplying again for 3, down, add. Multiply, up, down, add. 3, 9, 18. Okay, so every time we go down, we're going to add. Every time we go up, we're going to multiply. Okay, nothing fancy here. Okay, now this is my remainder. This is my new constant, x squared. And we're pretty much done. We just need to rewrite it. So negative x squared, okay, don't really need the 1, plus x, again, don't need the 1, plus 3 plus 18 over what we divided by, and we are done. Okay, that is it. Same thing. Just do practice one more time. Okay, now again, I can have a leading coefficient. This is fine, but I cannot have a coefficient on the x in the divisor. What we are dividing by cannot have a coefficient. I'm going to draw my setup. Constant, 2, negative 2, positive 3. Okay, I do not need any placeholders here. It counts down nicely for me. I'm going to take the sign, flip it, put it in the box. So -1, put it in the box. Drop, multiply, multiply by the box, add. Multiply by the box, add. Multiply by the box, add. Remainder, constant, x squared. 3x squared minus 5x plus 7 minus 12 over x plus 1. Drop down, multiply, add, multiply, add, multiply, add. Remainder, constant, x, x2, and if there was more, x3, x4, x5, so on. Okay, so looking at these, both of these can be done with synthetic division. I have no coefficient. I do have it's x plus or minus something. Same thing here. Okay, again, no placeholders on this one. This one's gonna be easy. I do need to make sure here though that I add a placeholder. Okay, and that is going to be it for this section. So again, just I want to be super clear. Long division always works. Okay, I could have done long division with these two last problems. It will have done what we wanted. It will give us the same answer. It is quicker to use synthetic division. Drop, multiply, add, multiply, add, multiply, add, right? Versus trying to do this. Okay, but again, I can't always use synthetic division. I cannot use synthetic division here. 2 reasons. 1, I have an x squared term. Anytime you have x squared, x cubed, x fourth, whatever that you're dividing by, you cannot use it. And 2, I don't have a 1 in front of my x. I have a -1. Okay, same with this one. I cannot use it because I have an x squared and I have a coefficient on my x. It has to be just x plus or minus a number. Nothing else. That is the only time synthetic division will work. Okay, so please be careful when you're working through your problems on the section that you're making sure if you want to use synthetic division that it is a problem you can use it on. Okay, again, please make sure you're coming for RTI Fridays. I'm available 10 to 12 for regulars and 12:40 to 2:40 for honor students. I do like to keep them separated because it allows me to have more time focusing on the topics that we covered in class because the pacing is different for the 2 classes. So please try to make sure you are coming on the appropriate times. I am at lunch from 12 to 12:40. Okay, I do eat. I'm a person. I eat. Okay, so please make sure that you're trying to come between those times. I will stay if I need to, but again, I sometimes need to go get food. So please make sure you are coming those times. Tutoring before and after school, I'm available Mondays and Wednesdays after school. Schedule is posted in the classroom. Okay, let me know if you have any questions, and I'll see you next time.